Hello, everyone. Welcome back here. Today is going to be our last day on verifying trig identities. Okay, so this is Wednesday, so this will be our last day for doing this. Thursday, you will have just sort of like a couple more practice problems, and then you'll be getting your quiz. So your quiz will be uploaded on tomorrow, Thursday, and you will be able to work on that through the weekend up until Sunday night is when it will be due. All right. After that, we are going to go back and look a little bit more at solving. We did that with the unit circle. I don't think it went all that great, so I want to go back and do a little bit more on that as well. And then we'll be done trig by the end of next week, and that'll leave us with like a week or two left to do some logarithmic stuff. But anyway, so for today, I asked you to work on problems 9 through 12 on page 9 of this PDF file that we've been working on. So this is what we're going to be going over now. Then I'll have another video with the other page and problems that you had to do, and then we'll be good. Okay. All right. So let's take a look at these problems here. So again, when we verify, we have our equal sign. So we definitely want to make one side equal to the other side. We want to work on the side that is harder, has more going on. So in this case, number 9, definitely the left-hand side. Now for this one, when I look at this one, again, on the left-hand side, I don't see any squares for Pythagoreans. I do see a secant which we could change. However, I see something more algebraic first that we could do here. Whenever you have an addition or subtraction over a single term, it is best to separate each term. So secant x over secant x minus cosine over secant should equal sine squared. Well, the nice thing here, secant over secant cancels out to 1. Now, remember in this problem, we did something like this above. I said before, if you multiply reciprocals, so sort of put this up top here, when you multiply reciprocals, so if I do cosine times secant, let's see, cosine times secant, you always get 1. But when you do the division of that, if I did cosine over sine, then you do not get 1. Be aware of that, okay? So for this problem here, that's what we need to look at. We need to say, all right, well, cosine, let's turn that into a fraction, make it cosine over 1. All over secant, let's make a fraction by 1 over cosine. And again, all that should equal sine squared. Okay? So we got our 1 here, and we got to do our keep change flip. So we'll keep cosine the same. That's going to drop the 1 off. Division turns to multiplication, and we flip the second fraction, which again is just cosine. Hopefully by now you guys can sort of see ahead that, oh yeah, okay, here, look, I get 1 minus cosine squared equals sine squared, which I know 1 minus cosine squared is sine squared theta equals sine squared. Check. All right. So I think we did one like that similar up above, but we're just going over it again here. Now for number 10, obviously the left-hand side is what we want to work on. I don't see any addition or subtraction, don't see any squares. So this would just be our problem. We want to turn everything into sine and cosine. So cotangent turns into cosine over sine times secant is 1 over cosine. All of that is 1 over sine when we change cosecant, and all that should equal 1. On our top part of the fraction, we have 2 fractions, put them together, but don't we notice that our cosines can cancel out? So we're left with 1 over sine all over 1 over sine equals 1. Now you can notice right away that, oh, I have a fraction with the same exact thing in the numerator and denominator, so that cancels out to give me 1 equals 1. So we'll put a little check there. Or if you want to show it, we could do the old keep the first fraction the same, change division to multiplication, and flip the second fraction. Doesn't everything else also cancel out, so we get 1 equals 1 that way. So if you recognize algebraic rules and ideas, please use them. We're going to save you some time. Okay? Excuse me. All right, on to number 11. All right, so number 11, obviously, again, our left-hand side is what we want to work with. In the numerator, though, I do see a Pythagorean identity, 1 plus tangent squared. Wasn't 1 plus tangent squared secant squared over secant? I'm not going to change that because look at my answer. I want secant in my answer. So this is pretty simple now. I mean, secant squared means I have 2. Secant in the numerator, 1 in the denominator. So can I get rid of 1 here and get rid of 1 there? And very simply, we got our answer. Check. That's bad there. So sometimes, like even though you see secant, look at what your answer is, because I wouldn't want to change secant into 1 over cosine because it's going to have to change it back then. So always look at your answer as to what you have. For number 12, again, my left-hand side is going to be the one that I want to work on. There's a different Greek letter here. Don't worry about that. It's still supposed to be theta. That's a misprint. So what do we do here? Well, here we're going to FOIL. Binomial times binomial. And if you notice, we are multiplying a binomial times its conjugate. So what do we not get? We don't get the middle term. So don't worry about doing the O and the I. Just do the F and the L. So I get 1 minus cosine squared equals 1 over cosecant squared. Doesn't 1 minus sine squared equal sine squared? 1 minus cosine squared, sorry, equals sine squared. Again, we want to get it to look like this. So I know if I take the reciprocal of sine, get 1 over sine squared theta. That's not right. 1 over cosecant theta equals 1 over cosecant squared of theta. Check. So those weren't too bad. Some of those are really short, actually, so hopefully you got those here, okay? Now, the next page, I actually didn't require you to do, but I just want to go over this with you real quick because this is important. These 6 problems are important for the last page. So let me, you know what? Let's see something. How many problems here? 8 problems. Yeah, you know what? Let me do these real quick. So these are all, if you notice, addition and subtraction problems. And the most important thing with addition and subtraction, again, is that you need to have a common denominator. So the first one is pretty simple. It's just a simple number problem. Remember, you can always multiply them together to get a common denominator of 12. So the first fraction, how do I get to 12 from 3? I got to multiply by 4, which means I need to multiply that 2 and top by 4 as well. Same thing with the second fraction. I need a 3 in the denominator to make it 12. So I'm going to multiply the 1 by 3 to get 3. And we get 11 12. So it's the same idea here with trig functions. So for this one, again, we can always multiply our trig functions together to get a common denominator. So in the first fraction, what's missing? Well, there's a sign missing in the denominator, so I have to multiply the 1 by the sign to just get sign, plus, make sure you bring the operation sign down. And then for the second fraction, we are missing a cosine in the denominator, so we have to multiply that. Now, unfortunately, this is not really a process to getting an answer. Well, it is a process, but with this problem, there's nothing else that you can do. We stop here. This is just showing you how to get a common denominator. I would never give you an answer in that form, but that's just the process that they're showing you what to do. Okay, well, C is the same thing. Okay, C is the same thing. I'm going to multiply those together. Well, don't I know that this is 1 minus cosine squared? We did that above, right? Multiplying a binomial by its conjugate into a middle term. So you could do that. Okay, you could do that. Or if you don't like doing that, like say to yourself, you know what, I don't want to do that. I want to actually write it as 1 minus cosine times 1 plus cosine. There's nothing wrong with that. And you'll see in a second as we go through how we'll finish it. But anyway, so what's missing in the first fraction? Isn't there a 1 plus cosine missing? So I got to multiply by a 1 plus cosine in my numerator. Then again, bring down the main addition sign. What's missing in the second fraction? 1 minus cosine. Now this one we can simplify. If we notice, don't we have a cosine and a minus cosine in the numerator? So that turns into 2. Now here is where I will write this as 1 minus cosine squared. Okay. What is 1 minus cosine squared? Well, we know that that is sine squared. And this goes back to our problem here where, yes, we simplify, but we have a fraction answer. If sine squared is in the denominator, we can use the reciprocal to give us 2 cosecant squared. Not too bad. Letter D, here's one. You can always make a fraction by putting 1 underneath it. So what would our common denominator be? What would our common denominator be? 1 times tangent would just be tangent. Well, aren't I missing that tangent in the first fraction? So don't I have to multiply the numerator by a tangent to get tangent squared? Okay. Minus, well, since I don't need anything in my denominator, I already have it, then my numerator just stays the same as well. Okay. Now this one again is a little tricky when you do this. You got to remember, some people say, oh, this is 1. Well, not quite. Let me show you again. 1 plus tan squared equals c. So that's the original identity. So I need to subtract this over. But if I subtract that over, don't I still have that 1 there? So I have to subtract the 1 from both sides, and what you end up getting is tan squared minus secant squared actually equals -1. So be careful. Sometimes the way things are moved around, it may give you a little bit of different values. So what that means then for this problem is in my numerator, I get -1 over tangent, just tangent, -1 over tangent. Again, that's a fractional answer. I don't want to have that, so 1 over tan we know is cotangent. But don't forget that negative sign follows along as well. Okay? So the idea of getting common denominators. And 2 more in this video here. All right? Same idea for this one. I would put this over 1. What's my common denominator? Cotangent. Well, nothing is missing here. I mean, I have tangent here already. But on the right side, on the right fraction, after the plus sign, I do need a cotangent, so I'm going to have to put a cotangent here. Okay? Now for this one, we can go a little bit further because we can turn our things into sine and cosine. So I got sine over cosine plus cosine over sine all over cosine over sine. Now remember, some people might say, oh, look, I can cancel out my cosines over sine. No, not with the addition. You can't do that. So what I need to do is, so here's my main fraction right here. Here's my main fraction. I have cosine over sine in the denominator. But in my numerator, I need to get another common denominator. Well, I can just multiply these together again to get cosine times sine. But in my first fraction here, I'm missing a sign, so I'm going to get sine squared. And in my second fraction, I'm missing a cosine in the denominator, so I'm going to multiply that to plus cosine squared. And here's our famous identity there. That's going to be 1. So what do I get? Well, I get 1 over cosine times sine. Keep, okay, change division to multiplication, and flip the second fraction. Okay, so there's your keep, change, flip. If I notice, oh, I can cancel something. I can cancel this and this. What am I left with? I am left with 1 over cosine squared, which again is a reciprocal. The reciprocal of cosine is secant. So it just turns into secant squared of theta. Okay. And the last one, I'm not quite sure why this is, but the last one is the same as the one up here. So it's the same as letter B. So no, I'm not going to redo this one. So it's the same as B. Okay. All right, so I'm going to stop this video and I'll pick up with our last video for this